We've already looked at the idea of a sequence and a series in general, with a sequence being an arrangement of numbers in a particular order and the series being the sum of the elements of a sequence. We're going to look at a specific type of sequence today called an arithmetic sequence. An arithmetic sequence, again, a list of numbers, is also called an arithmetic progression. And all it means is that we're adding the same amount each time. So if we have two terms, say 3 is the first term and 5 is the second term and 7 is the third term, notice each time we're adding 2. So we can define those terms in the sequence using a general formula. Any term in the sequence, a general term, can be defined as the first term of the sequence plus n minus 1 times that common difference for the sequence. Every sequence can be used to determine that series that goes with it, so the sum of the terms. And what I want to show you right now is the idea that any non-trivial arithmetic series is going to diverge. Remember, if we denote the terms of the sequence with a sub 1 being the first term, and the second term would be a sub 1 plus d, and the third term would be a sub 1 plus d again, because note this would be equivalent to a sub 2, and so on, we can add up the first n terms of the sequence. So for example, s sub n would be a sub 1 plus a sub 1 plus d plus a sub 1 plus 2d plus a sub 1 plus 3d, and so on up to a sub 1 plus n minus 1 times d. Notice these are equivalent to a sub 1, a sub 2, a sub 3, a sub 4, a sub n. If we add all of those terms up, we can write that in summation notation, going from I equals 1 to n of a sub 1 plus I minus 1 times d, which we can then separate out into I equals 1 to n of a sub 1 plus the summation of from I equals 1 to n of I minus 1 times d. Notice that as we keep getting larger and larger values of n, s sub n is going to continue to grow. Notice a sub 1 itself is going to be added n times.